In this video, we're going to cover what does the graph of the second derivative tell us. So second derivative just pretty much tells us concavity. If f double prime is positive, that tells f prime is increasing, which tells f is concave up. So there's a couple different ways you can tell concavity. One way is that the second derivative is positive. The other way is that the first derivative is increasing. Realize positive and increasing are different things. Increasing means it's going up, right? And positive just means it's above the x-axis. So we just need the second derivative to be above the x-axis. So if you have, a graph of the second derivative, it can be anything going on as long as, well, it can't be that. That's not even a function, but it can be anything as long as it's above the x-axis. Now, that's if it was f double prime. That will tell you that f is concave up on that interval. If it's f prime, it has to be increasing. So it has to be going up in order for f to be concave up. So there's a difference between the two. I know they closely relate, but you got to distinguish that difference. A lot of people think that because it's positive, automatically it's increasing. Well, yeah, if f double prime is positive, then f prime is increasing, right? But if f double prime is positive, doesn't mean f double prime is increasing. It just means that it's positive, which means that f is concave up. So this really lays it out for you. So distinguish the difference there. Really think about that, because that's going to help you. And I think we talked about that in the past video over here. Kind of looks like I went over that same subject last week. So I was going to give space for right here to say that exact same thing again. So if f double prime is positive, then that tells us that f prime is increasing. And ultimately, it tells us that f is concave up. Similarly, if f double prime is negative, then f prime is decreasing, which tells us that f is concave down. So let's look at this function. Remember, we're going to use a calculus-based reason here. So what is an appropriate calc-based justification of the fact that f is concave down? So, we can look at the graph there and see that's a sad face. So, this would be an okay justification for algebra 2 or math 2 or whatever. So f double prime is decreasing. Remember, that doesn't tell us that it's concave down. We could have the second derivative being positive and decreasing. It could be positive and decreasing. If the second derivative is positive, then f is concave up. So be careful with that. That's what I'm trying to tell you. So f double prime is negative, which it is because it's below the x-axis. F double prime is negative, thus making f concave down. So remember, f double prime could be decreasing and positive, which would make f actually concave up instead. So be careful with that. Don't put f double prime as decreasing. What is an appropriate calculus-based justification for the fact that f is concave up? That's simply because, not because f double prime is increasing, but because it's above the x-axis, because it's positive. So I'm going to go ahead and put C, because f double prime is positive. What's an appropriate calc-based justification for the fact that h has a point of inflection at h equals c, or x equals c? So remember, we want point of inflection, if you remember, or an inflection point means a change in concavity, right? So we want to see that change in concavity. So second derivative is going from positive, handwriting's awful this morning, to negative. See, it's above the x-axis, and then once it gets to c, now it's below the x-axis. So we have that change in concavity. F double prime is changing from positive to negative. So let's look for that. That's the calc-based justification. Obviously, a non-calc-based justification is because it looks concave up and then it opens down. So h double prime crosses the x-axis from above it to below it. So it crosses the x-axis. That's what's going to change that concavity, and that's what we see right there. Last, given that g prime is 0, so remember this means that x equals c is a critical point. What is an appropriate calculus-based justification for the fact that g has a relative maximum? So remember, if we're concave up, if f double prime is positive, then we're concave up. That creates a minimum, if you remember from a couple sections ago. And f double prime is negative, that means that we're concave down, which means that there's a maximum. So we want to see if there's a maximum at C, that means that our second derivative, which it is, negative. So G double prime of C is less than 0. It's negative. And that being right, if you look at B, that G is concave down, that's correct. But we're going to justify it with calculus. How do we know it's concave down? Because the second derivative is negative.